so that everybody can see. It appears that you've heard about the news that there's something big happening in Erie coming up. Me too. And so for the past, well, it seems like my whole career, I've been at Barron for 26 years, and a long time, every year I talk about eclipses in general, and I always say the one in 2017 was coming, and then it came and it went away, and then I said, okay, wait for the 2024. And unbelievably, now it's 2024, and it's upon us. What is it, 44 days or 43? What is it? I think it's 44, I think, today. Anyway, we should check it. But it's not unique to Earth and Moon. In the solar system, eclipses happen all the time. In fact, they happen more frequently around the giant planets because they have whole systems of satellites. There's over 70 moons around Jupiter. There's over 80 or 90 moons around Saturn. And those moons, especially the ones close up and the big ones, they cast shadows all the time. And so they're, on Earth we have maybe 1 to 3 solar eclipses a year, but there's dozens of solar eclipses in a year for Jupiter. And also the eclipse shadows on Jupiter. Everything's bigger for Jupiter. Jupiter's a bigger planet. The moons they tend to be bigger than most moons in the solar system, and the shadows cast onto Jupiter are bigger. But it's the same effect that the satellite, the moon, is casting its shadow into space, and that the shadow touches the planet. And it seems like, well, it happens all the time, dozens of times per year on Jupiter. Why is it relatively rare for the Earth? And that's my goal today. Sometimes with the Hubble Space Telescope, you can actually see more than one shadow being cast at any one time. This is a false color image of Jupiter, but you can see the shadows cast. Now, in the past, people have been observing eclipses. In fact, animals, non-human animals, have been observing eclipses for as long as they've been paying attention. In fact, during the eclipse on April 8th, the biologists, they will pay attention to bird behavior and small animal behavior, maybe even dogs and cats. You should also pay attention to their behavior as well, because the sky will change, the local background lighting will change. Anyway, people have been seeing these things for thousands of years. They didn't understand what was going on. In fact, it was a surprise for most everyone. But over time, people did record when they took place. They didn't have a calendar system like we do today, but they recorded, say, how many days between when the last one occurred and now. And they feared these things because they didn't understand. They thought it was a sign of maybe upcoming disease, or some catastrophic event, maybe some climate or weather event, or starvation, or a sign of impending battle. Maybe they were going to get invaded, or something terrible was going to happen. But later on, if you recall your 8th grade lessons on Greek and Roman history, around 400 BC, they actually have traced back. You can actually do this with a computer now. You can trace back when the eclipses would have happened throughout recorded history. And there was one traced back during what's called the Peloponnesian War between the Greek city-states. And that eclipse frightened so many people on both sides that they stopped fighting. For fear that continuation of their bad behavior was unappealing to the gods. And then Columbus knew about a lunar eclipse because he had tables of when the lunar and solar eclipses were likely to happen. They weren't perfect tables, but they allowed him to predict. In his last voyage, 1504, he and his crew were stranded on Jamaica, of all places. And to survive, he employed or threatened the natives to help them out, find food and shelter and all that. Well, they overstayed their welcome, and the natives said, no, we're not going to feed you anymore. Good luck to you. And Columbus used the lunar eclipse in that year, in March, to frighten the natives. And he said, listen, if you don't do what we're asking you to do, provide us food and shelter until we're able to get off this island, then the moon will turn bright red, exhibiting the wrath of God in front of you. And that's exactly what happened. And it frightened the natives, and Columbus and his crew then successfully were fed and housed until the summer of that year, and they successfully escaped Jamaica. So, a lunar eclipse. How many have seen a lunar eclipse? So, a lot of hands. I've seen lunar eclipses, and oftentimes, not every time, but oftentimes during a lunar eclipse, the whole moon turns red for the same reason that the sun turns red or orange on the horizon. It's that when sunlight of all the colors, the rainbow of colors, including the blues and the violets and the greens, when all the colors pass through the atmosphere, it's the reds and the oranges that make it through the atmosphere more efficiently. More of that color makes it through for physics reasons, which you, believe me, don't want to suffer through that explanation. But so when you see that orange-red color on the horizon, this is exactly what's going on during a lunar eclipse. Because during a lunar eclipse, the sun is there, the Earth is here, here's the night side of the Earth, and the moon is out where you are. Okay, so what happens is the sun actually goes through the atmosphere along the edge of the planet and gets filtered out. The blues and the greens and the violets get filtered out, leaving behind the reds and the oranges, and which get sent to the moon, and then we see the moon eclipsed, and oftentimes it looks red. A time-lapse sequence during a lunar eclipse shows the Earth's shadow, the size of the shadow compared to the size of the full moon. And it always happens in a full moon because the moon is on the opposite side of the Earth that the sun is. You'll see that in just a moment. Did something go wrong? Okay, so again, a time-lapse sequence. The full moon, if everything's in perfect alignment, the shadow of the Earth starts to eat away at the moon, and until the moon is directly within the Earth's shadow, and you would think, well, it would just look dark. In fact, I have seen, after the eruption of Mount Pinatubo in 1992, it sent so much ash up into the atmosphere that during the eclipse of that fall, it was either 92 or 93, the moon was not red, it was actually dark, dark black, because it was in the Earth's shadow, and there was very little scattering of red light in the direction of the moon. So this is the moon coming out. So this takes a few hours for the moon to go through the eclipse shadow and then out again, and that also is what we're going to experience on April 8th with the moon passing in front of the sun. And you may have seen eclipse paths like this on one diagram. The thing is, with the lunar eclipse, when a lunar eclipse happens, half the planet can see it. So that means 4 billion people all at once have access to a lunar eclipse. Now, only half of those people, on average, will be not subjected to clouds, right? So 2 billion people all at once can see it. And that's why, when I asked how many have seen a lunar eclipse, most of us have seen a lunar eclipse, because it's accessible to half the planet. The opposite, or the extreme opposite, is true for solar eclipses, because look at these paths. This is the path of the moon's shadow on April 8th. Here's the one in 2017 in August. How many saw that one? Right. In Erie, we didn't get a total, so we weren't exactly underneath the shadow, which went through the center of the country, but we still saw 85% of the sun covered up in August of 2017. Anyway, you can ask the question, how many people live under these blue curves? And it's about 0.1% of the area or the population of the planet, which means that when one of these shadows touches the Earth, it touches maybe tens of millions of people. All right, so if you're an eclipse, if you're a total solar eclipse enthusiast, what you can do is you can travel to these shadows, right, and take boats. And there are people who, these eclipse travelers, they travel the world, and there are some people alive today who have seen over 30 total solar eclipses. I am a lazy eclipse enthusiast. I've been waiting all my life for this shadow to come to me. So here it is, and it is this year coming to us, and we have access to the glory of the experience of totality, which I'll explain in just a moment. But it's a very rare event for any one location on the planet. So for the average observer, right, who's lived in 4 places in Pennsylvania and New York over about 50 years and paying attention to eclipses, there have been 77 partial total lunar eclipses for me in those places, and I've observed about 19 of them because of weather or because I wasn't paying attention or something. So that's 25% of the available lunar eclipses that I've observed. Right? And then also in that same time, 18 partial. I haven't been in the total, but 18 partial. And I've observed or been made aware of 7 of them because of clouds and personal business not observing. And that, if you do the numbers, so 39% of the solar eclipses observed. So the point is that more people see more lunar eclipses in their lifetime, but when a solar eclipse happens, then more people focus their attention on it because it's a relatively rare event for that one person. So I've seen 40% of the ones that I could have seen in the places that I was living. So you can do the same math with that. And I just mentioned that these things have been recorded and seen for thousands of years, and so as soon as people were able to start recording their history, the cuneiform here is thousands of years old, there is a record of eclipses, right? So they were dramatic events, and like I said, they sometimes affected the outcomes of battles, then they affected the development of the civilization itself. If you were an astrologer and your job was to keep track of eclipses or predict or to make sure that they were known and that they got good enough, they had tables to be able to predict. Anyway, your job was to tell the king or the queen that one was coming. And if you got the dates wrong, or if you didn't see one was coming and it came anyway, then you were subject to punishment, oftentimes execution. Right, so it was life or death for some of these individuals and civilizations. And Jones, Archimedes, also known as the Antikythera, and it's actually so it's thousands of years old, and this device was recently unearthed, and we know that it keeps track of the positions of the sun and the moon in the sky, and it had the ability to predict eclipses way back when. Right, so we're not the only ones who have been keeping track of this stuff. But having said that, we now have the ability on computers to know precisely where all the planets and the moon and everything in the solar system is, to within a meter. Right, so we can keep lots of decimals on the computer, and we can tell within a meter. And with the ability to do that, we can predict eclipses thousands of years into the future. We can also go back in the past and see when the eclipses would have taken place on the Earth a long time ago. But now you want to know, maybe you came today. Now you're going to ask a deeper question. Well, why? What is going on to cause maybe the frequency of eclipses that we see, or the kinds of eclipses that we see? And so that's partly my mission today to explain it. It's kind of like when people tell you February 29th happens every 4 years, and we put it on the calendar, it's a leap year, right? And you say, oh, Okay, we're just going to add a year, a day to this year, and everybody's okay with that pattern and memorizing that thing. But if you ask the deeper question, why do we do that? Then it becomes complicated. There's an astronomical reason for it, fundamentally. There's a socio-political reason for it, having to do with Julius Caesar and Augustus Caesar and the development of the modern calendar. All right, so today, you know maybe how eclipses happen. They have to do with the Earth and the Moon. But what is going on, those deeper questions, some of it's easy to understand, like the Earth and the Moon are going around the Sun. So this is the Earth's orbit around the Sun, and it's interesting to think of them as a pair, and while the Earth is going around, it's dragging the Moon with it, and they both go around once every year, 365 days. The Earth is 93 million miles, the Sun is down here below the table, 93 million miles away from the Earth and Moon, and the Moon itself is 250,000 miles from the Earth. And so this is the familiar phase cycle for the Moon. Here's the direction of the Sun, so it's coming from the right here. And then this is when we have new moon. You can't see the moon during the day, and that's exactly the situation on April 8th. The new moon, which we wouldn't normally see, can actually be seen. The far side of the moon, which is dark during that situation, blocks the light of the sun. It's a little misleading because when you see these phases of the moon going around here, it looks like every time you have a full moon, it should enter the Earth's shadow. And every time you have a new moon, we should get a shadow cast. It looks like you should have eclipses all the time. Just like in Jupiter, on Jupiter, the cases where we have the satellites going around Jupiter much faster looks to you. You should be always able to cover up the moon with your finger. Right? And so even when they say it's a super, how many have heard of the word super moon? Right? And now the news today is that we're going to have a micro moon. And what they mean is that it's further away from the Earth slightly. All right, so here's another maybe clearer version of what you just saw. So the ecliptic, that's the Earth's orbit around the sun. This is the moon's orbit around the Earth, and it's not that inclined. It's only inclined by 5 degrees. So that's the difference between this and that. You know, it's hardly at all. But that means that every time the moon passes the sun in the sky, or if it passes behind the Earth on the other side, it's always above or below the sun or the Earth's shadow. So we almost never get eclipses. And you can get eclipses if you see one in October or November, December, whenever you happen to see it, then say, okay, 6 months from now, we might get other eclipses taking place. So, and it has to do with the moon is going around the Earth. The sun is pulling on the Earth. One of the things the students learn in my intro astro classes is gravity is the force between all objects in the universe. And so you can think of the moon as going around the Earth unperturbed, unchanged by anything else that's going on. That's false. Because the sun is the elephant in the room, and the sun is also pulling on the Earth, and it's pulling on the moon, and it causes the orbit of the moon to precess like a top. And I was doing this before. That's... Sorry. That's fun to see, and it's familiar. Maybe we've seen this before, that precession. That's actually what's going on with this hoop. The elephant in the room, which you don't see, is the pull of the Earth on this spinning thing. And that pull of the Earth does two things. It causes it to go from standing up to going down. But it doesn't go down easily. It's almost like it rejects that pull, and then it starts to precess like so. And it precesses with a period which depends on the amount of pull that it has. In the case of the moon around the Earth, it precesses not because of the Earth's gravity, but because the sun is yanking on the moon as it goes around. And it precesses once every 18 years. Who cares? Why is that important? The entire sun or not. But there are other cycles involved. The moon's orbit is not stationary, and also the shape of the orbit is changing as time goes on, which changes the size of the moon in the sky, which is about a half a degree. So every elapse. Anyway, the only reason why the moon covers the entire sun is because they're about the same angular size in space, but the moon is a lot smaller than the sun. The Earth is a lot smaller than the sun. The shadow cast by the moon onto the Earth is only about 100 miles wide. It's a very thin thing. Occasionally, the inner planets, Mercury and Venus, there's Mercury, travels in front of the sun. We call it a transit. It's a rare event. It's like an eclipse. And it's known, we know when these things are going to take place. So I knew back in May of 2016 that Mercury was going to pass in front of the sun. And so I used a small telescope and I took a picture of it, and there it is. This is a sunspot, which is actually on the sun, but this is Mercury in front of the sun. And just to give you a sense of perspective, Mercury is really small compared to the sun. And this is the sun seen in ultraviolet wavelengths. And this is Mercury along the edge. The moon, by comparison, is about half the size of Mercury, right? And yet, from our perspective, the moon is the same size as the sun in the sky, and that's because while the moon is 1/300th the size of the sun, it's 1/300th closer. It's 1/300th the distance, and so the angular size of the moon and the sun just happen to be about the same. The other thing to keep in mind is that these shadows travel at thousands of miles an hour across the face of the Earth. Why is that? The moon is orbiting the Earth once every month, and if you calculate the distance that it travels and the time it takes, what is the speed of the moon in space? It's it's close to 2,000 miles an hour around the Earth. And that means that the shadow should also be going 2,000 miles an hour across the face of the Earth. It can go a little bit slower than that, though, because while the moon is moving, the Earth is rotating underneath the shadow, which reduces the apparent speed of the shadow across the face. And how much speed do we gain? The center of the Earth is going at about 1,000 miles an hour around the center. So the equator, if you live along the equator, you're traveling at about 1,000 miles an hour around the center. For us in Erie, it's around 500 to 600 miles an hour. At the pole, it's 0, right? Because you're standing on a spinning thing, which is rotating underneath you. 500 miles an hour from the velocity of the shadow, which makes it 2,500 miles an hour, which it would be in Erie, to something like 2,000 on Eclipse Day. This is the passage of the shadow in an hour and a half in 2017. So where were you in 2017? If you were in Erie, you saw a partial eclipse up in here, but if you were along this path, you saw a total eclipse, but it only lasted for a few minutes in your neck of the woods, because again, the moon is traveling at thousands of miles an hour. The Earth is rotating underneath, which lengthens the eclipse time a little bit. Right, so this is what's going to happen in April 8th, 2024. The greatest eclipse, the smallest shadow velocity is right there, which is about 1,500 to 1,600 miles an hour. By the time it gets up to Erie, it's whipping 3,000 to 4,000 miles an hour, and then it just whips right off the planet into space. Right, so this is where it leaves the planet, right there. So the slowest it's traveling relative to the surface is right about there, and the width of the shadow doesn't remarkably change. It's around 100 miles, 100 to 120 miles across, and we just happen to be in Erie, close to the eclipse shadow center. The center is actually in the middle of Lake Erie. I wouldn't on April 8th get in a boat and go into unless it's a calm day, and if you have a good boat, you could lengthen your eclipse experience by traveling 10 miles off the coast of Presque Isle, but we're going to get 3 minutes and 40 seconds from Erie Center on Eclipse Day, and northeast as well. I think it's a little bit shorter here, but not much.
So added
Getting faster in here, and so it's roughly the same there as in Erie. So 3 minutes and 40 seconds. That's actually one of the longest places on the shadow.
And what time of day are we?
Yeah, this is the moon starts to eat the edge of the sun at about 2 o'clock in the afternoon. By 3:18, it's maximum. That's when the glasses come off. I'll show you. If you wanted to lengthen your eclipse experience by a little bit, what you do is you buy a ticket on Delta Airlines, and they're actually selling these tickets. They're going to fly from Austin to Detroit, and they're going to try to follow the eclipse shadow to lengthen your time. Now, if this is traveling at thousands of miles an hour, that is not the speed of an airplane. All right, so an airplane can go, 500-600 miles an hour. So it will stay with the shadow for a time, but it only increases your duration in this situation by about a minute. And this is actually also a good way to segue into what to expect during totality. It will not become black as midnight. There will be light coming at you from outside, from regions of the atmosphere outside the shadow, right? So the horizon, when during the peak of the eclipse, when the shadow is right overhead, well, when the shadow is maximum for us, it's not going to be right overhead because the sun's going to be off at some angle. So here's the horizon, and it'll be like 45 degrees above the horizon, so about halfway up. And during that situation, you'll have light coming from you from outside, from regions of the atmosphere outside the shadow. So it'll be like dusk. So 2017, everybody remembers, in Erie, it was 80-some% coverage. October 14, 2023, it was rainy here, and it would have been 42%. A partial solar eclipse, here's one in 2014. We actually did see this locally, and the moon traveled like this. It didn't cover up the sun. It went like this, and so this was the maximum coverage for Erie, Pennsylvania. All right, so let's just move on. Okay, so 2024, we get maximum coverage, and this is when the glasses come out, right? So 2 o'clock. Well, even before 2, if anybody's staring at the sun, and they will, as soon as you tell the kids there's an eclipse this day, then you want to get out the glasses. And for me, I brought this pair of glasses. I think we have glasses to share with everyone before you leave today. But these glasses, they're covered with a film. I think Mylar it's sort of like aluminum foil, and it looks like when you put them on, you can't really see anything, but you can see the sun through these, and that's about it. And so definitely at 2 o'clock, but even before, if you're tempted to look up at the sun to see what's going on, you're not going to see any detail. You'll see the sun's circle in the sky, but you want your glasses on. And if you don't have maybe you're with a group of people, maybe your family, and you have maybe 1 or 2 pairs of glasses, it's not a disaster because the eclipse is really slow. It takes a long time for the moon to go from the edge of the sun to the center of the sun and cover up the whole thing. Right? So during that hour, you can easily pass the glasses around and just share the glasses when you need them, right? And then when things happen really quickly, during totality, which I'll explain and show in just a moment, that's when the glasses come off, right? So you really don't need a pair of glasses for every person. I would just if you have children in the audience around you, it's just don't stare at the sun. If they glance up at it, that's fine. But it's where you stare at the sun for any length of, and I can't do it without. It's really painful to me because I have super sensitive eyes, and so I wouldn't even be tempted to do it. But if you don't have enough glasses for everybody around, that's not a problem. Just make sure that when you do get close to totality, everybody's going to be wanting these just like this, and if you're staring, you want to make sure that the glasses are on. But when the last flickers of sunlight creep out from the edge of the moon, what's happening there is that the sunlight is actually tunneling its way through the valleys and mountains of the moon on the edge, right? And it looks like, we call this the diamond ring effect, because there's going to be flickering and flashing of light along the edge of the eclipsed sun. And these were first observed by Bailey, and so the astronomers refer to these as Bailey's beads, because he first described them, and maybe they were observed before then, but they were first in print, May of 1836. Who was Bailey, an English astronomer? There will be a quiz after. And so when you see these flickerings, then if that's the start of totality, then take the glasses off, and then you'll have 3 minutes and 40 seconds of glory, and then you should have somebody keeping track. Maybe set your watch, set your cell phone or whatever, so that after 3 minutes and 20 seconds it would go off, and then that's when the glasses go back on, because then the moon will these beads will show up again, and on the other side of the moon, and that's when the eclipse is over. All right. So again, I mentioned that last October, 6 months ago, on the other side of the orbit, we had an annular solar eclipse. The path of annularity passed from there down into Texas, and this one in April, the shadow passes through Mexico and then up into Texas. Right around there is San Antonio. So the people in San Antonio have been treated, well, will be treated to 2 major eclipses, not totals, just this one is a total. Major eclipses in less than 6 months. Right, so there's the 2 shadows. Now there is a place in Illinois, Carbondale, Illinois. I don't know if anybody was or knows anybody from Illinois, or who knows where Carbondale is, but that place experienced the total eclipse in August of 2017, and so they're one of the only communities in the country, well, actually in the world, to experience 2 total solar eclipses in less than 7 years. Right. Illinois right there. The other, San Antonio, is right there. And there is the crossing of the 2 paths. This was in October. This is in April. So for Erie, and if you want to take out your cell phones and take a picture of this, the times to remember are 2:02. That's when the moon will touch the edge of the sun. By 3:18, it'll be right in the center of the sun, and then by 4:30, the whole thing is over. But where is the traffic? The traffic is going to build right at like 3:20, 3:21. People are going to be on the edges of their cars, and I don't know what to expect. The Erie County, Sheriff's Department and the road people, they are prepared. They're actually, they don't know what to do either. We don't know how many people are going to be in Erie County. The estimates are somewhere between 60 and 250,000 people visiting Erie County. Now the population of Erie County is something like 200,000, maybe a little bit less. Erie itself, Erie City, is like 100,000, maybe a little bit less. So if we double or triple the population locally, my advice is to get where you want to be for the day and then to stay there. There are lots of people who, though they want to maximize the experience by going to Lakeside, I would say Presque Isle is not wise, because there's one way in and there's one way out, right? So 60,000 people are expected on Presque Isle. How do you get the cars on and off Presque Isle? I don't know how they're going to have to shut the gates and prevent traffic. I'm not advocating anything. I'm just saying, be wise about what you're doing. For me, I'm supposed to be at Barron College giving a talk to 1,000 high school students from Pittsburgh, and that happens at noon. And so my personal goal, I live in Edinburgh, PA, so I'm going to have to be in the car, I think, by 6 or 7 in the morning to get to Barron. It depends on the weather, right? If it's a bright sunny day, then all bets are off. If it's cloudy, then who cares? There won't be as much traffic and much interest in it. Still, if it is cloudy, let's say it's sleet and rain and thunderstorms, whatever it happens to be, in the middle of the afternoon, 3 o'clock in the afternoon, it'll turn dark as night. Right? So that'll be special. It'll look like the end of days, you know. And the animals, they are effective. I've been told that Jim Gavio, who's the director of the Yon Planetarium, who was just on TV last night talking about the eclipse, he went to Kentucky in 2017, and he said the mosquitoes started to come out, and then the bats started to come out. The birds start to chirp as if it's time to go to bed, and other small animals, small critters respond in similar ways. And so at Barron College, we have biologists who they're going to try to pay attention to the behavior of animals and maybe the sounds of birds and stuff like that. We're not going to have mosquitoes in April, but it would be interesting to see what the birds do. So everyone in the country is going to be affected by this to different degrees. And so if you're along the eclipse path, you get 100% in the middle of it. And but if you're in California, you know, it's going to be 40-50% of it blocked off. And down in Florida, the same thing, right? So contact your family and friends and tell them what they're going to see. You know, the closer you are to the eclipse path, the better. Again, the eclipse path is about, it depends on exactly where, but it's between 100 and 130 miles across, right? So if you go too far south, I think Meadville, or even maybe closer to Grove City, somewhere between Meadville and Grove City is the edge of the path, right? And then the path goes up through Buffalo, Niagara Falls, Rochester. I have family in all those places. Burlington, Vermont, I have family up there. And then into Maine, you know, it's gonna be great if it's unless there's this giant storm system that comes up the east. Yeah, question.
Well, where it's like more towards the Carolinas on that map, where it says 80 to 90%,
Yes.
that's a partial eclipse, then,
Yes.
right?
Yes.
Okay.
Yes.
So they should still wear their glasses.
Oh, absolutely. Yeah, glass is all for everyone, all the time. It's only if you're in here will you take your glasses off for the few minutes of totality. All right. So during totality, you can you'll be able to see light from the edges near the horizon. This is actually the sun is eclipsed close to the horizon. For us, the sun's going to be way up here. And also what we're going to look for, this glowing stuff, that's the outer atmosphere of the sun called the corona, which we don't normally see. And so there are science teams around the country who are going to be videotaping using telescopes. But the totality is 3 minutes and 40 seconds, starting at around 3 o'clock, 3:15-ish in the afternoon. So obviously the best case scenario is with children especially is to have everyone with eclipse glasses. Barron College has secured I think 50,000 eclipse glasses and is distributing them throughout the county to all the area school districts. I hope it's all. I hope it includes Warren, PA as well. But that number 50,000 was calculated so that it would cover all the children in Erie County, as well as their teachers, I think, as well as everybody at Barron College, all the students at Barron College. You know, we're trying to give maximum coverage. I have eclipse glasses here, but I was just told also that the McCord Library has a few hundred glasses as well. So before you all leave, you're going to get eclipse glasses for everyone. All right, so that is the safe way to observe looking up at the sun. But while the eclipse is, even before the eclipse is going on, look down at the ground. Right? This is one of the most strangest, most beautiful things that happens during an eclipse. And I didn't expect this when I first observed eclipses back in '94. But what's happening there is that the leaves of the trees, now there aren't any leaves in the trees in April, but also buildings do this as well. Cracks in the buildings, they act as little pinhole cameras. And what happens is the light from the sun goes through these little pinholes, usually leaves, these are leaves, and it casts an image of the eclipsed sun on the ground during eclipse. And you may say, well, why doesn't this happen like every day, all day? When we see, in fact, when we go outside today, you should look for these images. You won't see them except during an eclipse, because during an eclipse, most of the light that is impinging on the trees and in the environment is coming directly from the sun. There's going to be a little bit of light coming from the sky, but when you go outside, if you ask, where is all this light coming from? It's blinding. Some of it's coming directly from the sun, a small fraction, but most of it is coming from reflecting off buildings, from the road, from the sky, from the just the air. There's light coming from all around. Now, from everywhere, every which way, that's reduced to the point where now you're actually able to see the distinct outline of the light from the direct light from the sun going through these the pinholes, either in building structures or in or with trees. And obviously, we won't have trees. So every day you should be able to see something like this. So we do get these images, but they're fuzzy because we're getting light from everywhere, and it makes the images that I just showed you indistinguishable from just the normal background. All right, this is the pinhole camera principle. So what this person's doing is sheltering their eyes in a box like this. This tree, or whatever the background is, it goes through the pinhole. Not very much light, though. That's the point. No pun intended. The light, though, goes through and makes an image upside down on this side of the box. This is called the principle of camera obscura. I don't know if anybody's ever worked with that, but you can design something like this. The problem is there's very little light that makes it through the hole. So this is a very dim image. So you have to do a long exposure to see anything. This is actually a real exposure made through a pinhole, and you can see the upside down cityscape and stuff. But it's the exposure length has to be many tens of seconds or minutes to get something as bright as what you're seeing here. So this is a real effect, and it takes place through holes in the leaves and holes in the buildings and bridges to see. But it's a relatively also easy way to view the eclipse. So what you do is you get a box like this and make a hole for your head, and then you make a hole like this, maybe a big one, and then you put aluminum foil over that thing, and then you take a pin and you make that hole as small as possible. And then you might not expect much light to go through, but for the sun, it's bright enough. You'll see the crescent sun, and then it'll get smaller and smaller. And then during the eclipse itself, maybe there will be a ring of lights. Like, so if anybody wants to mark these down, 2029 we'll have in Erie, we'll have a 60% coverage. 2040 we'll have another 60%, 64% coverage. And then if we're still alive in 2093, 96%, and then 2099, 94%, and then August of 2011, 92%.
I won't be around.
And then 2144, you can tell your great-great-grandchildren to look at this one. This is going to be a total solar eclipse, the next one that passes through Erie, and you can see the path right there. It starts near Alaska, and then goes down, sweeps down through the center of the country, through or through the northeast of the country, through Erie. Right, and there, here are some of the paths that I just mentioned. There's one in 2045. Here's the August, is that 2017 it is, yeah, April of 2024. What I like about eclipses is they get people thinking about science and astronomy when they could be doing other things, looking at their cell phones, looking at the internet. And what's remarkable about it, I just said that this is going to affect tens of millions of people. So tens of millions of people, as if they can't help themselves, are going to drop what they're doing and step outside and look up, and they'll in that moment be able to see the intricate and glorious machinery of nature for the first time. So thank you.